Hi, everybody. This is Talking Digital Industries, the podcast for technologies and trends that drive industrial enterprises. And I'm your host, Chris Brow. In our first episode, we explore the hype and reality of edge computing. This is one of the hottest topics in IoT at the moment, as it will bring about a renaissance on the shop floor. And I'm super happy to have these three exciting and competent guests here with me today. Ladies and gentlemen, for this discussion, I am joined by Mirko Ross. He is a co-founder of Digital Worx, and Ashwin.io. Is that pronounced correctly, Mirko?
Oh, we say Ashwin because it sounds more like Hindu Sanskrit.
Ashwin.
Yes.
All right. Yeah. So Ashwin.io, both companies have a strong IoT focus, and Mirko is also a very active researcher and coach on the field of open innovation, IoT security, and disruptive business modeling. And he says about today's topic, trust is the new value. Mirko, nice that you can join us.
That's for sure, Chris.
Next up is Brehm from Siemens Digital Industries, where he heads the Automation Systems and Products Unit. And Rainer says about edge computing, the future will be hybrid. Now, I'm pretty sure we're not going to be talking about cars here in this sense, but we'll get back to that later. Rainer, great that you can join us also.
Thanks, Chris, for having me here.
And last but not least, we have Michal Skubacz. I hope that he thumbs up. All right, that worked out very well. Michal is responsible at Siemens Digital Industries for industry software motion control, and he says application drives value. Happy to have you here also.
Great to be here with you.
So, gentlemen, I'm really excited. Once again, this is our first episode, and we're just going to see how it works off. And we're going to start off with the first question here, which goes to Rainer. Maybe you can tell our listeners out there the main difference between cloud computing and edge computing. Now, back in the day, I'm talking maybe like 10 years back, the whole, hype was about cloud. Now it's all about edge. What differentiates the one from another?
Well, I think edge is not really new. If you take your mobile phone out and see the computing power locally at your hand, you have an edge computer, and the applications that are running there are the functionality.
Okay.
Or you talk about autonomous driving. The car itself is an edge device because you do autonomous driving in the car, but it's still connected to the cloud and receiving data like navigation data or getting update.
Okay.
And the same is now applying on the shop floor. Like maybe 5 years ago, everybody was thinking, well, I need to put the data in the cloud and then some miracle will happen.
Right.
And we see now that a lot of topics can be done and should be done locally at the machine, at the plant. And it makes sense because if you need constant computing power or constant memory, it makes sense to do it locally. If you need temporary computing power like training neural networks, you can do that in the cloud. On the other side, the topic of latency, which is in automation very, very important. So you want to control a machine very accurate. Mm-hmm. And then basically, the distance from the machine to the cloud is not beneficial. So a lot of activity is going to be moved back to the edge. And it's like a pendulum. Like, you go centrally more to a cloud and the pendulum swings back and you see much more local processing power.
So basically, if I understood it correctly as a layman, the main difference is between data processing on a centralized level and on a local level. Is that kind of?
Right. With benefits, there are some benefits to do it centrally,
right.
But there are also a lot of benefits, especially on the automation side, if you do it locally on the machine.
Okay, and that brings me back to your hypothesis at the beginning where you said the future will be hybrid. Once again, maybe Michal, I can ask you this question. Do you agree with that hypothesis? And does this have to do anything with cars? I'm supposing not, but maybe you can...
Of course it doesn't, but I, do agree with this hypothesis. I think it's very true that the future is about hybrid connection of different technologies in order to provide the best overarching system. Mm-hmm. So cloud and edge, it's not like edge replaces cloud, it complements clouds because you would like to have certain functionalities very close to where the data is produced. Mm-hmm. Where the decisions must be taken, and you would like to have certain other functionalities in a cloud where resources are nearly unlimited and where you have information coming from many different systems. Mm-hmm. So you have those different systems with the different characteristics, and you would like to have a combination of all of that and provide the right overall result.
So you say they complement each other rather than some voices out there actually say, edge eats cloud. You wouldn't agree with that?
Well, I know that some analysts are saying that. but we see it really more complementary. And it depends on the application where more computing makes sense, but it's complementary. And I think something we are aiming for is having really a solution in both on the cloud, on the edge, but also on the control level. So having that interplay of these three levels is really the key.
Looking at Mirko right now, he has a smile on his face. Well, I haven't asked him the first question yet. But Mirko, both of your companies have a strong IoT focus, right? So what fascinates you about this whole topic of edge computing? And maybe you can give us some typical use cases, like what are typical use cases across the industry?
Yes, I think we have to look different. And I can show you two topics. I mean, one is the daily bread. If we talk about can we use edge computing for predictive maintenance? What can we do at the edge to, improve the production process directly on a sensor, on a controller, on a machine? I mean, that's to me a daily bread job. We can do that now, and even that's what industries is looking for currently and working on. And on the other side, we are working on our companies on a rather specific innovation level. And the innovation level is something like what we think, and that's why edge computing is so important. We believe that the centralized structure from the cloud are the past. We believe that decentralization is the most important topic. Because if we run into autonomous machining, into autonomous cars, we are stepping in a world where the entities will decide by themselves how to reorganize and how to control and steer. And that's completely edge, because that means that intelligence is on the edge. And it means something like we have a lot of edge computing devices which are forming a swarm. And this is swarm intelligence. This is beyond cloud. To me, it's beyond cloud. We see a paradigm shift for sure. And even I think we don't have the right words now to say, well, we try to find out, is it cloud or is it edge? But to me, it's rather clear that the future is decentralized. All what we see is decentralization because it gives us resilience in the structure, for example. But even if we step into a machine-to-machine economy where machines are paying machines and stuff like that, and that's what we are working on, I think edge computing is the key for that.
And I think the interesting topic is that, what Mirko just said is this kind of really embedded scenarios. You go down to a sensor, you go down in a machine. You need to have all the strengths of the OT world. But, all the scenarios of, bringing AI in, bringing this distributed compute power in, you need the IT technology. So you really see in that scenarios that OT and IT really comes together. And only with the joint forces, we can make that scenarios happen.
But still, let's try to stick to some actual use cases. That sounds like this could be something for everybody, for every industry out there. But maybe, Michal, you have, as an expert, some more use cases that actually show that this technology actually benefits or how it benefits for companies?
Let's look, for example, at some applications in which edge computer helps us to really understand the process. Like, for example, quality monitoring or process monitoring systems that gather lots of data from a local system, from various sensors, really tons of data gathered at a very high frequency and processes this information. This is something that you can hardly do in a different way than by actually analyzing data on the spot in the real or near real time. And then, of course, providing some insights to other systems, maybe systems running in the cloud. And I think it's also important to mention that many of those applications, like, for example, process monitoring applications, like some also safety-related applications or other applications that process a lot of data, benefit a lot from fast innovation. And that fast innovation can be reached through a combination of edge computing with right centralized learning, with right centralized systems that gather all the knowledge from different systems and distribute this knowledge back to the edge systems. So it's all about autonomy, yes, but it's not only, it's about separate systems that run separately and do something. It's about autonomy combined with sharing knowledge.
Maybe you can give us an example of, let's say, edge computing in use in the Siemens production site. Since we're in Nuremberg, there are many sites very close here. Rainer, where does it come into play here?
Well, I like the cases most where you combine edge and artificial intelligence. And I can give you 2 examples we are running in our plant in Hamburg. So one example is we're doing kind of a prediction on a spindle of when it fails, and we simply get signals like the torque of the spindle, and then we are analyzing when it fails, and we can predict pretty good when it fails. And that's a typical use case for edge. You get a signal then in your projection side in order to do maintenance. Another side is more on the process optimization side. So for example, we're producing printed circuit boards, PCBs, and the bottleneck in the PCB line was always the X-ray, because the X-ray in the past each and every circuit board to assure quality. Now the bottleneck was the X-ray, and now the question was, do we need to put 2 X-ray machines there in order to increase the throughput of the line?
Okay.
What we can do now, based on the process parameter of the soldering process and the temperature of the oven and so on, we can now predict if a circuit board has a problem or not has a problem.
Wow.
In 30% of the cases, we already know that the circuit board will not have a problem. So we are bypassing the X-ray in this case, and will go directly to the packaging unit.
And can still guarantee the quality.
Exactly, and that is real time. You need, because it's really going fast through the line, and you need to decide, goes it right or left? Goes it in the X-ray machine, or we're going to pass it?
Right. Wow, what a smart way to use that. Now, researching for today's talk, I stumbled across many articles that consider artificial intelligence as the key driver for the adoption of edge computing. And Mirko, you already touched base on that just a few minutes ago. And Michal, in a blog post you wrote on edge computing, you provoke with the headline, "Who is afraid of intelligent machines?" Well, the question goes to you. Are you afraid?
No, I'm not.
Is there reason to be afraid?
No, I don't think so. I think intelligent machines will help us, and many of those will be built based on edge computing technology. Because we've already mentioned AI algorithms running directly or in a machine. We will be able to give another or bring automation to another level. I mean, at the moment, many automation systems are highly repetitive systems, able to repeat a task very well, very precisely, cope with some uncertainty of an open world, but not too much. And when we mix it together with AI, then we will give the machine's eyes maybe similar sense as a human being would have in order to cope with uncertain world, with all the things that can happen, and to understand what's happening around a machine.
That is interesting. And that also, of course, brings up the question around security in this case. This goes back to you, Mirko, since I know you're an expert on this topic. You said trust is the new value. So you mean where data is the key, it also opens up a world of additional security headaches, probably for many people out there. So is edge computing becoming a new kind of cybersecurity frontline?
Yes, it's like always. I mean, we have many opportunities with edge computing, but at all, we are also opening some new threat vectors by that. First of all, of course, we are increasing the level how we expose devices because we connect them to the internet. That's for sure a threat we have to challenge. But there are other topics. I mean, we can do that by implementing as well monitoring systems and certain level of, as I said, trust. In the future, it will be rather important to know which kind of device are talking with humans or with other devices. And this is a question of the digital identity of a device. So can we create really digital identities which are bulletproof? This is one level of trust we need. The second level will be the trust in the data. Can we trust the data of the device? Because when we use this data, for example, machine learning, we are building, for example, our digital twins upon this data, and the digital twins will affect certain processes in the factories. So it will be an important topic. How can we create chain of trusts from the data source up to the processing? And when the processing will be on a machine learning entity, we have this certain problem for machine learning that even the machine learning algorithms, when they have been trained with data sets, they're like a black box. We have to trust what is the outcome of a machine learning algorithm. And this is still a problem because there is no possibility to look inside a machine learning algorithm. This is not possible.
Right.
So that's, I think, the most challenges we have currently. And at all, it's getting a cybersecurity topic. So creating this kind of trust layers to work with companies you trust or to have trust in the supply chain will become the most important topic for success in the future for the industries.
So this kind of also implies, just in my head now, this picture just popped up of not only humans having to trust the machines, but machines have to trust machines also somehow. They have
right, Chris.
Right?
I mean, imagine we are stepping into an economy where machines are dealing with machines. Autonomous entities of machines which have intelligence will do smart contracts with other machines.
Wow.
I mean, this is a completely new economy we're building. And even inside a factory, we're building completely new microeconomies in a factory process. And if this is the future, and I truly believe that this is the future, which is really a revolution, because if you tell this traditional machinery companies or something like that, they're mainly out of mind of this. But if I tell them, well, the future will be autonomous components inside your machine and will be a machine-to-machine economy, trust is everything.
Wow, that sounds amazing. And if I pass this question on to Rainer and Michal, maybe you can tell us what your approach is towards security. How do we secure the edge? How do we establish the necessary trust?
Maybe to add on what just Mirko said, I mean, thinking that further, I mean, in the past when Industry 4.0 started, we talked about cyber-physical system and autonomous system who can interact with others. But we only looked at that really from a technology point of view, what is the value add the device is bringing. We never thought, and absolutely with you, on the really financial terms as well. So if a machine is doing a value add, it should also get paid. And that is done between machines. You have payment suddenly between machines. And that's not engineered, because currently when you plan your line, you do engineering and you know A is talking to B. They're going to be dynamic. There might be a new machine coming in with a certain skill, and without engineering, they need to talk to each other and trust each other. And to make that sure, I think that's a very, very important topic. And that, that dynamic and bringing that in and bringing the technologies in to ensure, for example, that integrity is something which, again, coming back to edge, will be part of our industrial edge system, which makes that possible. And when we bring or develop our industrial edge offering, security is always one of the key topics. So the topic of cybersecurity, but also the topic of data integrity. Especially when you control machines, you need to make sure that nobody could manipulate the data. And also before we bring out our devices, we build it in, we think of what is all necessary. But also then, before we release it, we do a kind of penetration test in order to make sure that really that.
What does that mean? Penetration test for our listeners?
That is a kind of friendly hacking. So basically, we are hiring internal companies or internal entities
to hack your own system.
Exactly, to hack our own system.
Wow.
And they're good ones. They're not,
That's interesting. Just thinking of, machines talking to machines and we as humans not being able to understand them. Once again, trust, I guess, is a big issue. Michal, what do you say about this?
I think when we're talking about edge computing, then we are also talking about creating this new technology as we speak. And that gives us also a possibility to think about security from the very beginning. It's not like thinking about security, which is add-on, like in the last 5 moments before releasing the product. There was something, now I have to also think about security. When we create something new, we have a chance to actually build security by design in the architecture and think about it from the very beginning. And it helps us to do it in the right way. Security is only one aspect. Of course, trust is more than security. It's all about all different aspects of how systems are being used and how you make sure that they are being used in the right way. And it's going to be crucial because we will be making decisions in the future based on what different sensors and machines will be telling us.
And if we talk about edge computing and the Internet of Things, it also changes the way we do business. Now, let's just assume we got the security issue handled and everything's clear, everybody trusts, and this evolves. Where are the new profit zones when we talk about
I think edge computing will give us opportunities to do business in a different way because we will be able to manage software, manage applications, manage different offerings in a much more rapid and fast-paced way. Like, for example, adding some digital upgrades to machines, giving some functionalities, not at the very beginning, but later on when a machine is already in the field. And then that gives us also a possibility to combine applications, software with services. And of course, service comes with a different business model, with service business models, with improvement. So this is all driving an ecosystem of applications, services, and everything that is around it to make it much faster and much better.
So much more to come. Now, you're all off to an important event here in Nuremberg. The SPS fair is taking place, and I guess you're all going to be over there during the next couple of days. Talking about fast evolving technology like Edge, what are you looking forward to most at the fair? Is there anything you're really specifically interested in seeing there? Who wants to start it off?
No, I think I'm really looking forward to what kind of applications do we see bringing in artificial intelligence on the edge? What is the level, the current level? Because we are facing there, different challenges like limited processing power on the edge, for example, compared to the high supercomputer backup we have on some artificial intelligence stuff. So I'm really curious on what's going on there, because I think this will be a key factor for the edge success.
Thank you, Mirko.
Maybe let me step in just to answer your question, what we are showing. No, first of all, on the application side, for example, we bring two applications for edge computing. One we call SAM, Semantic Assistance for Machine, and it's really an assistant, like, for Alexa, for example, you can talk to the machine, but you also get answers. Built in, there's a knowledge graph, which is a kind of AI, where the machine understands the question and is collecting data out of the machine. Could be what are the components built in the machine, could be what tutorials are there, how to operate, how to maintenance, what was the maintenance record, but also, operating the machine. That is done in an app which is running close to the machine. One example.
But Rainer, the story of Siri and me is a completely story of misunderstanding. So because always when I ask Siri something,
Is she or he?
I don't know. So I hope when I ask your machine that this is not a story of misunderstanding, that this is a story of understanding. I think that's the true challenge.
Absolutely.
Let's just not get into pronouns here.
No, but that was one example. Another example, we also bring the digital twin, as you mentioned, on the edge, and we are executing digital twin in real time, parallel to the real machine, and that digital twin can operate soft sensors. So you get a signal from the machine, then you have the digital twin. It calculates another value of a sensor which you don't have actually in the machine.
Okay.
And you can use that value of the soft sensor, of the virtual sensor, to orchestrate your machine again. That's one nice example. But what I'm really looking forward is how we orchestrate edge in the OT world, and I'm looking forward also for discussion of how can we build up new ecosystems, combining different offerings from different companies in order to really build an ecosystem of edge.
As we see, Rainer, you're looking forward to a lot during the next couple of days. Michal, how about you?
Applications drive the value, as I said before, so that's why applications are key, and we are bringing many new applications around our products, applications to monitor our processes, to predict quality, also applications to analyze images in order to understand, for example, what's happening in a machine, to find out if the machine is able to start or if there is something probably in a machine workspace which could cause a problem. So giving those eyes to the machines. So we are not talking only about future, like maybe in 20 years some things will be happening. We are talking about the innovation happening now and applications that we bring and show at the moment, already existing applications.
So, unfortunately, our time has run out today, but I'd like to thank you all for coming out here. Thank you very much, Mirko. Thank you, Rainer. Thank you, Michal, for these insights. And also, thank you to our listeners for tuning in here today. I hope you enjoyed it as much as I did. And if you want more, just visit siemens.com/industrial-edge for additional info. And also stay tuned for our next episode. This was Chris Brow and Talking Digital Industries. Hope to hear you again soon.